Okay, we're going to look at Chapter 10.2, Independence, and we're going to talk about contingency tables. This is a pretty long process, so I'm going to show it to you by hand, then I'm going to run to the calculator and show you what has to be done there. Anyway, you work for an insurance company and you're studying the relationship between the kind of crash that occurs and the type of vehicle, like whether it's a single vehicle or multiple vehicle, or whether the vehicle involved is a car, a pickup, or a sport utility. As part of your study, you randomly selected 3,059 vehicle crashes, and you organized the resulting data in this contingency table. And at alpha equal 0.05, can you conclude that the type of crash depends on the type of vehicle? So the first thing we're going to do is identify the claim and state the null and alternative hypothesis. H of O is the type of crash is independent, means has nothing to do with each other. The alternative says the type of crash is dependent on the type of vehicle, and so your null hypothesis is independent and your alternative hypothesis is dependent. So the next thing says determine the degrees of freedom, find the critical value, and identify the rejection region. So this is a matrix. These are rows. There are 2 rows and there are 3 columns. Okay, and that'll become important in just a few minutes because that's like a 2 by 3 matrix. R stands for rows. I have 2 rows. And C stands for columns, and I have 3 columns. So to get the degrees of freedom in a contingency table, you say rows, which there are 2 rows, minus 1. Columns, there are 3 columns, minus 1. So that's going to be 1 times 2 gives you 2. R stands for rows, C stands for columns. Now, I'm going to turn to the back of the book and use Table 6 for chi-square. I'm looking at alpha at the 0.05 level, and so I'll find out if I look back there using my 2 as my degrees of freedom, look under 0.05 as your significance level, and you'll find that x squared of the null set is equal to 5.991. So my rejection region, that is my critical value there, and my rejection region would be x squared greater than 5.991. Calculate the test statistic. Use technology where it's convenient. Now this is a little tough because this is a lot of doing. But anyway, you have a matrix and it's a 2 by 3. So you take this total of the row times the total of the column. Here you go, divided by the complete total. Then you take the same total times the 602. So row times column. Row times the third column. So these are these 3 answers. Then you'll go to the second row and take that times the column. Take the second row times this column, second column, and second row times the third column. And each time you divide it by 3,059. And what you do is you put it in this table, and what you have is this. The first column is your outcomes, what you really found happen when you've checked on the crashes. These are your expected outcomes, and that's what I was figuring here. Then you take outcome minus expected outcome and get this answer, then square it and get this answer, and then take the squared answer, divide it by E, and you get 19.49. And you do that for each column. Outcome minus expected value gives me this answer, square it, divide it by E, and you're going to get 16.82. And so it adds up, this column adds up to 108.91. Now I want to run to the calculator and show you the calculator. And here's the calculator, and what you have to do is make a matrix. And these instructions tell you how to make a matrix, and this is for example 3 on page 556. And so so you'd have to just go to these instructions. They're under Tools for Success. If you have any trouble, just email me. But what you would do is you decide to reject or fail to reject the null hypothesis. And here I'm going to reject the null hypothesis because 108.91 is in the rejection area, so I would reject it. And here's my statement. Yes, at the 5% significance level, there's evidence to reject it.